The objective of this experiment is to interface keypad with LCD. As we can see, first we have initialized a 4 into 3 keypad matrix. The next is for LCD, where we have initialized reset, read write and enable. For keypad interfacing, first we set all the columns to high. Then various LCD commands like 38H, 0EH and 06H have been given. 38H stands for initializing the LCD as a 2 lines 5 into 7 matrix. 0EH represents cursor blinking and 06H means shifting the cursor to right. As we can see here, we have called the command label, which we'll discuss later. So for the working of keypad, as we saw earlier, all the columns were set to high, and now in the loop, all the rows are set to low. Whenever a key is being pressed, the corresponding column becomes low. So for example, if any row in column 1 is pressed, the program goes to call one loop. Now here we check all the rows one by one. So first for row 1, we set the row 1 as high and all the other rows as 0. Now if the intersection of row 1 and column 1 was pressed, column 1 will become high again, which means the program will now run to the code display 11. Similarly, for all rows the same thing takes place, and the same thing for column 2 and column 3 as well. These are all the display commands. As we can see here, we have called the data1 label. The command and the data1 label represent the code written for LCD printing. We have then provided a suitable delay. Thank you. After this, moving on to the Proteus simulation.
This is the Proteus simulation of a keypad. The keypad is connected to port 1 of the microcontroller. The LCD screen is connected to the port 2 of the microcontroller. When we press the keys on the keypad, the corresponding numbers are displayed on the LCD screen.
This is the code for keypad interfacing with LCD. As described in Keel simulation, we first set all the columns to high and all the rows to low. We then go into the loop. Here, whenever a key is being pressed, the corresponding column, here being column 1, becomes low. We then go into another loop, checking for all the rows. For row 1, for example, it is set to high. If the key 11 is pressed, then the column 1 becomes high again. We then go on to write a code to display the number 4. Now going into the debug mode, as we can see, when we press row 1, column 1, where the number 4 is being printed, LCD displays number 4.